Section 6.4, Inequalities in one triangle. There are several theorems in this particular section that are really important when comparing triangle lengths and angle measures. The first theorem says if one side of a triangle is longer than the second side, then the angle opposite the first side is larger than the angle opposite the second side. A lot of words, this is what it means. If you take a look at this blue line is formed by this angle. The red line is longer than the blue one. The angle opposite the red line is larger than the angle opposite just the blue line. You'll notice that the red line is formed by a 50-degree angle and the blue line is formed by a 30-degree angle. This is what it's saying. The angle opposite the longer side is the bigger angle. Longer side, bigger angle. Take a look at this particular triangle and tell me which angle is going to be the biggest angle. Put them in order from greatest to least. The second theorem is kind of the converse of the first, and it says if one angle of a triangle is larger than the second angle, then the side opposite the first is longer than the side opposite the second. So take a look at how this compass is working. You have an angle that made a line, the black line that's there. If I were to extend this angle, if I were to make that vertex angle larger, then the side would be longer. And this is the theorem in a nutshell. The side opposite the larger angle is the longer side. Take a look at this triangle and put in order from greatest to least which sides are the longest down to which side is the shortest. The side opposite the larger angle is the longer side. So the side that's the shortest is opposite the smaller angle. We have another theorem in this section that's called the triangle inequality theorem. And what it says is the sum of the lengths of any two sides of a triangle is greater than the third side. Consider, if you will, this particular triangle right here. It's not a full triangle, but this will give you an idea of why it has to work. If I take a look at that red side, you can see where it cuts on the third side of the triangle. Ditto with this side. You can see where that will hit the third side, and it won't meet in the middle. So the sides have to be longer than the third side. The two of them put together have to be longer, otherwise there won't be any angle in the triangle. Look at this particular one, and look at this side. If those two sides are not longer, then they would end up meeting somewhere here in the middle, and there would be no rise to get up to that angle B. The last thing that happens in this particular section is something kind of funky, where you put two triangles together and you're given some measures and you want to find out which is the longest side. Now I made it kind of over dramatic for you so that you can see, and you can probably tell by looking at it that side BC, line segment BC, is the longest of all of those. So let's take a look at this particular problem. If you look at triangle ABD, if you start off with that triangle, knowing the theorems that you were just given, AD would have to be the shortest side in triangle ABD because it's across from the 30-degree angle. And because angle A is a right angle, you can tell automatically that angle ADB must be 60 degrees. Now, here's the funny part when you're comparing two triangles that are attached to each other. Angle A, the 90-degree angle, makes this side BD. Next, what I'm going to do is I'm going to take a look at the angle measures from the other two angles that are missing in triangle BDC. Well, you see that AD and BC are parallel to each other, which would make this angle 60 degrees by alternate interior angles. 60 and 50 give you the 110, so angle BDC must be 70. I'm going to give you a hint and tell you to start with the triangle that's to the left. It always seems to work. Across from the 90-degree angle, in this particular triangle, the longest side would be side BD. But if you'll notice, side BD is across from the 50-degree angle. So in triangle BDC, this side is the shortest side because it's opposite the smallest angle. Because this is across from the 60-degree angle, this is the middle side, which would mean that side BC has to be the longest side out of all of them that are in this picture. We're going to be doing a few more of those in class, but for right now, just remember, start from the smaller of the two triangles and work to the bigger of the two.